All right, welcome back. I just wanted to do kind of a simplified overview of reaction mechanisms. So the idea is that every single chemical reaction, let's say we have this chemical reaction here, 2A plus 2B turns into CD. Every single chemical reaction is actually not just this one-step process. Typically, there are multiple steps that are happening, and intermediate chemicals, notice right here, X is not in the overall reaction. So this is what we call an intermediate, meaning that this is created and then used up. And so here's our rate law for this particular reaction, and here's my my three-step mechanism for this reaction. So my mechanism has 1, 2, 3 steps, and there's 2 fast steps and 1 slow step. So first of all, let's identify the intermediates. We already talked about 1. We have X here as 1 intermediate, and then Y here as 1 intermediate. How do you know it's an intermediate? Well, it's going to appear in the steps, but not in the overall reaction. All right, so one of the things you need to do with or maybe we can prove this by adding this all up. If you are to take these reaction mechanisms and let's say add them all up. So I'm going to take all the reactants and add them all up. So I got A plus X plus B plus Y plus B. And then I'm going to take all my products and add them up. Now what I'm going to do is I'm going to take out my I don't want my intermediates in here, right? So there's going to get rid of all those X's and Y's because those are intermediates. All right, now I'm going to go ahead and rewrite this. So I have 2A plus, and I got 2 B's. 2B goes to C plus D, and that matches. So that's kind of one way of checking your reaction mechanisms. They may ask you to, if these reaction mechanisms will work or which one doesn't belong. So that's sort of how you do it. In a way, you just kind of set it up like an addition problem. Now here's another thing. Let's go ahead and figure out if this rate law here matches up. Now the first thing you need to do is you need to say, well, the slow step is going to be what we call the rate determining step. So slow step is the rate determining step. And why is that? Well, it's because the whole reaction has to wait for the slow step. And so because it's the one that holds everything up, it has to determine the rate because nothing can go faster than the slowest one, right? So if this whole thing is relying on this slow one finishing, they all have to sit around and wait for it. All right, so let's go ahead and look at our rate law. So here's the one that we know has to match up to our rate law. So now when we look at our rate law, we say, okay, but wait a minute. In this slow step here, because remember rate law only uses the reactants. We're only looking here. We have K equals X times B, but X isn't even part of the overall reaction. So you can't do a rate law with an intermediate in it. So what we have to do is we have to say, well, what does X equal? So if we look back here, X equals A plus A. So there's 2 A's here, and that's what X equals. So A, if you go ahead and insert, then basically substitute what X equals. X equals A times A, essentially A squared, right? So you could, let me just go ahead, I'm going to take that out of there. I'm going to go ahead and rewrite that. So K, we could say A to the second order times B. So sure enough, that does work. That rate law does actually work right there. So that's kind of how you would match up a rate law with a reaction mechanism. Look for the slow step. If you got an intermediate, look at what that intermediate equals. Do the substitution in there, and if it matches up, then you got it. If it doesn't, then something's gone wrong. All right, let's see here. In the next video, what I'm going to go ahead and do, so this is just kind of a quick overall reaction mechanism things. I'm going to go ahead and look at radioactive decay. We want to bring in the idea, we talked about half-lives with reaction mechanisms and kinetics. Well, radioactive decay, when atoms fall apart, is always first order decay. So we can use the half-life stuff from from our previous videos on first order equations or first order rate laws in order to figure out radioactive decay. So we're going to work on that one next.